like a Hellcat.
Hi guys, so welcome back sa ating YouTube channel. So ito na yung ating sunod na lesson o continuation sa mga videos natin or sa mga discussion natin dito sa abstract algebra. So in this video, pag-uusapan nga natin yung mga elementary properties of group. So meaning na elementary, yung pinakauna or isa sa mga pinakamalaga. Actually, properties naman talaga ni group talaga is yung una yung pagiging close o yung define yung binary operation, associative siya. Next is nag-exist yung identity element, tapos last is yung nag-exist yung inverse. Okay, so may inverse yung kada element natin. So dito medyo parang kumbaga pinalawak lang sila. So kumbaga andi dito sila probably. So for example, we have theorem 1.41. So we have the uniqueness of the identity element. So in a group G, there is only one identity element. So again sabi ko naman to dati pa sa mga previous video, nag-iisa lang yung identity element. So ang sabi dito, in any group G or in a group G, so arbitrary G yan, arbitrary group G yan with asterisk, so there is only one identity element. So how do we prove this? So consider natin ito. So dito para ma-show natin na siya ay unique, to show uniqueness, kasi ito ay one identity, so meaning unique siya. So to show uniqueness, we need to set two different things. So for example, sabi niya isa lang yung identity. So dati nga sabi kung may limit, so sabi niya isa lang yung limit niya. So nag-set ka ng dalawang limit, tapos dumating sa point na equal yung dalawang limit na sinet mo. So katulad din dito, mag-set ka ng dalawang identity, dapat at the end of the proof maging equal yung dalawang identity element. Okay, so let's start with this. So consider, or to improve, consider a group G. Consider a group G comma asterisk. Again, that is arbitrary group and arbitrary binary operation. So meaning group yan, alam natin na define na lahat ng alam natin. Okay, so let A, so let E and E prime be the identity element of G. Identity elements of group G. Okay, so meaning nagset ako ng dalawang identity element which is si E and E prime. Okay, so now by definition, okay, so for every A element of G, we have A asterisk E is equal to E asterisk A is equal to A. Okay, yan yung una nating nakuha. Okay, next is by definition ulit dito tayo. So by definition again ng ating monoid, so for all A natin element of G, we have A asterisk E inverse E prime. So meaning knowing the fact na si E prime is also identity, so kaya na rin gawin yung ginagawa ng E na identity natin. So A asterisk E prime is equal to E prime asterisk A is equal to A. Okay, note na si for all A element of G is arbitrary element of G. So again, arbitrary element si A. So pwede nating iset na si A dito ay si E. So again, since A element of G, pwede natin siya iset. So set natin, so set A to be E prime. So we have E asterisk E prime is equal to E asterisk E prime, which is equal sa E prime. So let me call this equation number 1. Next, dito rin sa kabilang to, so since A is arbitrary element of G, pwede natin siyang iset as E. Okay, so again, si E kasi is element din ni G. So again, arbitrary si A, so pwede siya maging identity element. So let us set this as, so set natin dito si A to be equal kay E. So this is equal sa E asterisk E prime, which is equal sa E asterisk E, which is equal sa E. Okay, next is by transitivity, obviously E asterisk E prime ando doon siya, no? So kung napansin mo, E asterisk, so nagbago, no? So anong nangyari, dapat baliktad ako ng ginawa dito, no? Tama, no? E prime, so dapat dito si E prime. So ito yung E prime, ito yung E, sorry. Okay, so E asterisk E prime, E asterisk E is equal to E asterisk E prime is equal to E prime. E asterisk E prime is equal to E prime asterisk E is equal to E. So knowing the fact na E asterisk, so naman E prime asterisk E, doon siya, E prime asterisk E equals sa E. So aware tayo ito ay equal sa E prime and ito equal sa E. So by transitivity, by transitivity of equality, we have yung E prime na to equal lang dito. So we have E is equal to E prime. So the identity element is unique. And therefore that is done. Okay, so ganun siya kadali i-prove. Okay, so after no ating theorem 1.41, so we have theorem 1.4.2, which is the cancellation law. So dito may cancellation din tayo ditong tinatawag. So note, balik tayo sa ating notation. So nabanggit ko nga last time na sabi ni sir, for our notation or for convenient ng ating mga proof, kumbaga para mapadali, we have A asterisk B is just equal sa AB whenever variable yung ginagamit. So kagaya ng ginawa ko dito, AB can be read as A asterisk B. Okay, so again, A asterisk B is equal to A asterisk C. So now proceed tayo sa theorem 1.4.2. So we have if A, B, and C element of G. So again, element sila ng G, where G is a group. So tandaan mo, G is a group. Then number 1, if AB is equal to AC, then we have B is equal to C. Number 2, if we have BA is equal to CA, then we have B is equal to C. So, napansin mo may positioning yung A na yan. So, note this is the RCL. So, meaning na RCL is right cancellation law. Kasi sa right ka nagtanggal ng A, na-cancel out yung A. Dito is left cancellation law. This is LCL. Okay? So, ang gagawin ni sir is ipoprove niya lang si right cancellation law. So, proof natin. So, per activity na lang isa. So, proof of theorem 1.4.2 number 1. Okay, so ipoprove natin. Yan. So, since nakalagay siya na if then, so napansin niyo no, if then, so we have assume. So, pwede natin gawin yung ginagawa natin dati sa punda. Pwede naman yun. Assume that AB is equal to AC. Show natin na B is equal to C. Okay, so now we start with assume. So sabi nga nila, mag-start ka sa assume, tapos pakita mo yung show natin. Okay, so consider natin. So consider AB is equal to AC. Okay, so dyan tayo nag-umpisa. So now, ito yung alam natin na una. Aware ka na element ni G si A. So, since, lagay ko lang, no? Since A is an element of G, and G is a group, then, A inverse is also an element of G. Tama ba? So, again, since A is an element of G, at alam natin si G is group, aware ka nandyan si A inverse. So, element ni G si A inverse. So, now, pwede natin gamitin yung A inverse na yan. Yung A inverse na yan is imumultiply natin dun sa ating consider na AB is equal to AC. So, we have A inverse AB is equal to A inverse AC. Okay? Next is by associativity. So, by associativity or by ASO, we have A inverse AB is equal to A inverse AC. Okay, next is, by anong property yung ginagawa dyan? Yung A inverse A. So, by inverse, dito na lang. So, by inverse property, so by inverse, yung A asterisk, yung A inverse A is equal sa E B is equal to A inverse A is also equal sa E, C. Okay, then by identity, by definition of identity, we have E asterisk B is just B and E asterisk C is just C. So this is B is equal to C. Therefore, this is done. Okay, so ganun siya kasimple. So again, ginagamit ko lang yung mga property na since alam kong group siya, aware ko andyan yung identity element, alam ko andyan yung inverse. Okay, so dapat naiintindihan yan. Okay, so yan yung right cancellation law. So note, pwede natin gamitin yan. O pwede mo tawagin. So sabihin mo lang by RCL, cancel na siya. So hindi mo na kailangan dumaan sa ganyan. So yun yung kagandahan ng theorem na to. So by RCL or LCL. So depende. So again, hindi ka pwedeng mag-cross cancellation. So hindi ko naman sinasabing hindi pwede, pero ang rule lang natin o yung theorem na to is right cancellation and left cancellation. So hindi tayo pa pwede na sabihin na, sir, pwede mo cancelin to. AB is equal to CA. So hindi pa basta-basta kasi may rule tayo, no? Kasi ang idea nito, ang ginawa mo, kung saan ka nag-multiply ng A inverse sa right side, nag-multiply ako sa right. Ay tama, sorry, sa left. Nag-multiply ako sa left. So dapat sa left ko rin i-multiply. So ayun din yung isa sa mga pwede ang mga rule dito. So kung saan ka nag-multiply or nag-asterisk, dun lang. Kung sa left side, sa left side. Kung sa right side, sa right side. So parang baliktad ako, no? So kung sa left side, sa left side. Kung sa right side, sa right side. Ganun dapat. Okay, so ito ay cross cancellation. So hindi pa natin ko consider. So I guess parang magiging activity niyan. So pag-iisipan niyo paano niya siya ma-prove or ma-disprove rather. Okay, let's have theorem 1.4.3. So we have the uniqueness of the inverse. So sabi ko nga, sir, paano unique? So ibig sabihin ng uniqueness of inverse, so gaya ng sabi ko, kung si A inverse na si B, dapat si B inverse lang niya si A. So ibig sabihin ng pagiging unique, inverse lang ako sa isang element. So inverse lang kami sa isa't isa. Hindi ako pwede mag-inverse ng iba pang element. Yun yung ibig sabihin dito. Okay, so yun yung, baka kasi isipin mo, sir, isa lang po inverse. Hindi ganun yun. Okay, so uniqueness of inverse meaning inverse ka lang sa nag-iisang element at inverse lang kayo sa isa. Hindi na kayo pwedeng maging inverse ng ibang element sa loob ng G. Okay, so now let G be a group. So ito yung sabi ng theorem, no? So let G be a group. So for every A element of G, so for all yan. So for every A element of G, the inverse element A inverse is unique. The inverse of element A inverse is unique. So, baliktad yan. The inverse element, A inverse is unique. So, A inverse ang basa dyan. Note, ang A raised to negative 1, ang basa natin is A inverse. So, sabi siya ay unique. So, again, I guess, ipoprove natin siya sa ibang different manner. So, I guess, hindi ko gagamitin yung A inverse. So, isaset ko lang siya na, kumbaga, so, ito yung proof. Pag-isipan ni sir. So, mag-let tayo. So, let B and C be the inverses. Be the inverses of A element of G. So, kumuha ko ng dalawang bagay. So, dalawang element B and C na inverses of A element of G. Okay? So, note, since B is the inverse of A, so we have ano ba yung property ng inverse? Ang sabi niya, B asterisk A is equal to A asterisk B is equal to E, or simply BA is equal to AB is equal to E. So by notation. Okay, so let me call this equation number 1. Next is since C, okay, since C is the inverse, is also the inverse of A, so we also have the same thing, which is CA is equal to AC, which is equal sa E. Okay, so note, so equation number 2 to. So equating natin yung equation 1 and 2. So equating equation 1 and 2. Equating equation 1 and 2. So, meaning na equating, pipili lang tayo ng pwede dyan. So, for example, pinili ko si BA and CA. So, itong left side lang na to. So we have BA is equal to CA. Tama. Then by, obviously, tatanggalin natin si A. By right cancellation law, tama ba? By RCL. So by RCL, so baliktad yata ako kanina. So yun, tama, baliktad si sir. Ito ay LCL. So kasi sa left, nabobo ko sa sa positioning. So ito ay LCL, ito ay RCL. Yan, buti na tama na siya. Buti na dito pa tayo. So hoping na na mabantayan mo yung sinabi ko dito. So again, by RCL, cancel na lang yung A na yan. So we have B is equal to C. So meaning equal yung B and C, equal yung dalawang inverse. So A inverse. So A inverse is unique. Therefore, this is done. Okay, so ganun lang siya. Simple. Okay, then next is number 4. Theorem 1.4.4.4, we have the uniqueness of the solution. So, ano ibig sabihin nito? Kumuha ka ng A asterisk B, may specific siyang sagot. So, for example, 1 plus 2, ang sagot is 3. So, that is the uniqueness of the solution. So, ang ibig sabihin lang niya, pag kumuha ka ng iba, for example, 1 plus 2 is equal to 3, tapos kumuha ka sa 2 plus 3 is equal to 3, hindi pwede yun. Okay, so yun ibig sabihin ng uniqueness of the solution. So, A asterisk B, may result yun. So, hindi siya pwedeng makuha ni hindi siya pwedeng makuha ni C asterisk D. Hindi pwede yun. Okay, so yun ibig sabihin ng uniqueness of solution. So, now, let G be a group with asterisk, with respect to asterisk rather, and let A and B element of G. The equations AX is equal to B. So, ibig sabihin ng AX is A asterisk B. The equation A asterisk X is equal to B and Y asterisk A is equal to B have unique solutions in G for each pair of elements A and B. So, yun nga sabi niya, no? May unique solution siya for each pair of A and B. So, ito yung gagawin natin. Since ang gusto niya is ma-show yung uniqueness, kaso ang nangyari is we have AX is equal to B for every A and B. Hindi pa natin alam kung nag-exist yung solution. So, meaning, ang unang goal ng proof natin dito is to show, to show the existence of the solution. So, unang way or ipuprove natin is to show the existence of the solution. Once the solution exists, therefore, pwede natin i-show yung uniqueness. Okay, so, proof. Okay, so we need to show first the uniqueness of the solution. So consider natin. We need to consider AX is equal to B. So ito lang yung pinili ko. So hindi ko na pinili si YA is equal to B. So consider AX is equal to B. So note, same reasoning sa taas. Since A is an element of G at alam ko na group si G, then A inverse is an element of G. Okay? So, meaning, anong gagawin natin? I-asterisk natin yung A inverse para makancel yung A na yun. So, yun kasi yung goal natin. So, this is A inverse AX. Since minultiply ko siya sa left side, i-multiply ko lang din siya sa left side. So, we have A inverse B. Next, by ASO. So, by associativity, we have A inverse A X is equal to A inverse B. Next, by inverse, so again, inverse yan yung property niyan. So, by inverse, magiging E siya. EX is equal to A inverse B. Then, by identity property, we have X is equal to A inverse B. So, tanong, exist yung A inverse asterisk B, element ba ng G? So, yun yung tanong ha, again. Si A inverse, element ni G. Saan galing si B? Si B galing kay G. Si A inverse, element ni G. Ngayon, ano ang result ng A inverse asterisk B? Since parehas silang galing kay G, obviously, element sila ni G. Okay, so obviously, this is an element of G. Okay, so, X is equal to A inverse exists. Okay, so nag-exist yung solution natin. Okay, now, proceed tayo by uniqueness. So, to show uniqueness of solution, o to show uniqueness, okay, let tayo. So, let x sub 1 and x sub 2 element of G. Okay, so such that, so may dalawang bagay. Kung baga nag-let tayo ng dalawang dalawang solution which is x sub 1 and x sub 2 such that x sub 1 is equal to A inverse B. Tama? And x sub 2 is equal to A inverse B. So, parehas sila. Magkaiba sila pero parehas ng format. Okay, so now, we need to show na si x sub 1 is equal to x sub 2. So, paano natin gagawin yan? Okay, so may babaguhin ako ulit ha. Let x sub 1 and x sub 2 element of G such that hindi ko to gagamitin masyado ng obvious kasi pag yan. So, hindi ko gagamitin yung existence o yung nag-exist na solution. So, such that, ang goal natin, we have ax sub 1 is equal to b and ax sub 2 is equal to b. So, obviously, so since doon ako kumuha. So, which is okay lang. Now, by transitivity, since si b, pareha silang equal si b, so, we have, so, ax sub 1 is equal to ax sub 2. Okay, now, since A is an element of G, A inverse is an element of G. So, we have A inverse AX sub 1 is equal to A inverse AX sub 2. Actually, pwede ka na nga mag left cancellation do, pero umpisa ko na, go na natin. So again hindi ko sinasabing sir, bawal ba mag left cancellation do? Pwede naman left cancellation do, okay na tayo dyan. Pero syempre, gawin ko na to. So by ASO, kasi natuloy ko na rin. So by ASO, we have A inverse A X and we have A inverse A X sub 2. Okay, and we have by, ang sabi to, so by inverse, we have EX sub 1 is equal to EX sub 2. So that is by inverse. So, lagay ko nang sa gilid. Then, we have x sub 1 is equal to x sub 2. Then, that is by identity. Okay? So, therefore, x sub 1 is equal to x sub 2. So, meaning, nag-i-exist yung dalawang solution na. Or meaning, unique yung ating solution. Kasi x sub 1 is equal to x sub 2. So, the solution is unique. Okay, and therefore, this is done. Okay, so ganun siya. Simple. So again, magagamit mo ulit to usually sa mga proving natin someday. So pag may nakita ka na pwedeng i-apply si uniqueness of solution, okay, apply mo na siya, then go ka na dun. Okay, so again sabi ko dito, pwedeng mag left cancellation na lang, then tapos na tayo. So x sub 1 is equal to x sub 2. So proceed na tayo. Next ko na lang, lipat ko na lang para di na tumagal. Okay, so for the last topic or last theorem in this video, kasi next video natin is about proving problem. So magpo-prove tayo ng mga proving problem dito sa abstract algebra using yung mga properties na nakita natin. So we have theorem 1.4.5, the inverse of a product. So actually this is also known the socks-shoes theorem. So this is also known as socks-shoes theorem. Okay, so sabi ni socks-shoes theorem, so let G be a group and let A and B element of G, then we have AB inverse is equal to B inverse A inverse. So nagkabaliktad, no? So kumbaga, sir, bakit mo ba nasabing socks-shoe theorem? So ibig sabihin ng socks-shoe theorem, ito yung logic pansinin nyo. Pag nagsuot ka ng sapatos at medyas, ano na una? Medyas tapos sapatos. Paano mo huhubarin? Siyempre, una si sapatos bago si medyas. Ganun dito. So, parang sinuot ko yung medyas, sapatos. So, parang nangyari, sinuot ko yung sapatos sa medyas. So, parang kumbaga, sinuot ko yung medyas din sapatos. Nung hinubad ko, siyempre, una na si sapatos bago si medyas. Ganun yung dating. Ulit nauna si medyas, sapatos. Kung kinuha ko yung inverse, anong mangyari? So, inverse. So, uhubarin ko, meaning ng inverse is unahin kong hubarin si sapatos bago si medyas. Kaya siya socks-shoe theorem. So, yun yung ibig sabihin niya. So, napaka-powerful nito. So, ito ay property ng ating group. So, lagi mo yan magagamit. So, by theorem 1.45 or by socks-shoe theorem, magagamit natin. Yan. So, now, ang tanong is, paano natin siya ipoprove? So, again, medyo tricky to. So, hoping na magigets mo yung idea ni sir para dito. Okay, so, consider natin to. So, here's the proof. Ito yung proof. Okay, so, consider natin consider natin si AB inverse. Okay? So again, si AB inverse is element of G. Aware tayo dyan. Okay? So si AB inverse is element of G. Ngayon, ang tanong, ano yung inverse ni AB inverse? Ano yung inverse? So meaning, ano yung inverse? So, inverse ni AB inverse. Ang inverse ni AB inverse is simply AB. Tama ba ng logic si sir? For example, si A inverse. Ano inverse ni A inverse? So, that is A inverse raised sa inverse. That is A. So, ganun lang dito. So, ano ibig sabihin lang ni sir? Anong pakahulugan ni sir? Ang pakahulugan ni sir, si AB inverse equal kay B inverse A inverse. Okay? Si AB inverse, ang inverse niya si AB. Ngayon, ang gusto lang pakita ni sir, na si AB inverse ni B inverse A inverse. Again, si AB inverse ni B inverse A inverse. Okay, so ngayon, ipapakita ko yung two-way na yan. So, paano two-way, sir? Ang una kong gagawin is, yung AB inverse, multiply ko sa AB. Okay, so aware tayo, no? So alam natin na si AB inverse. So lagay ko lang So AB inverse AB is equal to E. So sure tayo dyan based dito sa ating observation or sa kinonsider natin. Okay, so sure tayo dyan. Okay, yan yung claim natin. Ngayon, ito yung ating gustong i-show. So we need to show. So, para masabi natin inverse yan. So, aware tayo ulit inverse na yan. So, aware tayo na si AB inverse equal dito. Okay, so we need to show na si B inverse, A inverse, multiplied by AB ay equal kay E. Ang goal lang natin, kailangan si B inverse A inverse times AB is equal sa A. Kasi nga, sabi nga, si AB inverse equal kay B inverse A inverse. Na ang alam natin na si AB inverse A inverse na si AB. Okay, so meaning, ang goal natin, pakita natin to na equal sa A. So consider natin, consider si B inverse A inverse AB. Okay, so note by ASO. So by ASO we have ano mangyari dito? By ASO we have B inverse A inverse A tapos B. So bagay drop ko sa gitna. Next by inverse we have B inverse, then this is E and B. Okay, then by ASO pili na lang tayo. By ASO we have B inverse tas i-group natin si EB. By identity, so by identity property we have B inverse B, and by inverse ulit we have E. So B inverse A inverse AB is equal to E. Therefore si AB inverse is equal kay B inverse A inverse, and that is done. Okay, so ganun siya kasimple. So again, yan si Sakshu theorem. So lagi siya magagamit. Okay, yan effect ni Sakshu theorem. So thank you for watching. Ito lang yung topic natin sa video na to. So yung properties ng elementary properties ng group natin. So again, hoping na panoorin mo next video natin, kasi next video natin is about proving problem. So magpo-prove tayo using yung ating mga theorem na yan